Hello and welcome to the deployment demo for CiBot, the continuous integration Slack bot we're building for software engineering. We're deploying using the Microsoft Azure platform with a virtual machine running Ubuntu Xenial. And we're also using a Vagrant VM with Ansible to run the deployment playbooks. Our first playbook, setup YAML, first updates Python so that we can use Ansible's get URL command, which we can then use to update Node.js and NPM to a version compatible with the most recent version of the Forever tool. We then install Forever globally, clone our CiBot repo, and execute npm install. We decided to separate the starting and stopping of the bot into separate playbook files, which we will now demonstrate. Startbot.yaml simply starts the appropriate Forever process for the bot, and as we can see, the bot comes online after the script finishes. Stopout.yaml halts all Forever processes currently running on the virtual machine. As we can see, this effectively shuts down the bot. One more item of note before reviewing our use cases. In case the bot crashes, we are using John Slinkert's data store tool to save GitHub tokens, mappings of Slack channels to GitHub repos and users, and vice versa, as a JSON file on our virtual machine. Our first use case covers the initial setup of Travis CI on a repo, as well as the integration of coveralls. And the first step of this process is to use our new add token function to allow CiBot to remember your GitHub repo token. This will allow CiBot to create YAML files and push them to the repo, as well as create and assign issues to participants. And this is actually a function that we've restricted to direct messages with the bot only, so you're not sharing your tokens over a shared channel. Okay, so we are now ready to activate Travis, integrate coveralls, and push a YAML file onto a live test repo. And we've used Slack's existing channel system as an organizing principle for our bot. What this means is each repo that we use CiBot with will have its own distinct channel within Slack. And as you can see here, the SlackBot repo currently does not have Travis CI activated, and there's no Travis YAML file in the repo. And as long as CiBot has been added to the repo channel, we can use a direct mention to call the init Travis command. And in this screencast, we'll be primarily showing happy paths, but if you want to see some sad paths and error handling, please refer to the previous screencast. And as we can see, Travis has been activated. And if we refresh, we can see there's now a Travis YAML file. And we're going to fast forward through the build a little bit, but a build is triggered, and we can see it goes successfully. And as we can see, when the build finishes, we get a message on the proper channel with the coverage information. And just to demonstrate CiBot handling multiple repos, we'll repeat the process on a second distinct repo on a distinct Slack channel. Again, we can see that Travis has been activated for the repo, and if we refresh, we have a Travis YAML file, and a build has begun, and we'll fast forward through this as well. And when the build finishes, we get a notification on the proper channel with the coverage details. And in this case, the coverage is below the threshold, which is a use case we'll handle in use case 3. For our second use case demo, we'll show how CiBot handles build failures and what options it gives to resolve them. So the first step is actually to break the code, so we'll do that here. And when the commit is made, a build will automatically be triggered with Travis CI. And we'll fast forward through this build again. We can see that it fails. And back on our Slack channel, we see that we've received a message indicating the build failure. So now we can use the create issue CiBot command to assign someone to the issue on the GitHub repo. And to see an example where we change the issue titles, please refer again to the first screencast. And as we can see, CiBot has created an issue with the proper assignees and title. And to finish out the use case, we'll show the process to amend the build failure. But if you just want to skip to the next use case, go ahead and go to the next title screen. Alternatively, at this point, we could include the fixes keyword in the commit description to go ahead and close the issue. And if there are any further issues, then we'll be notified again, so it doesn't really cause any problems. So after making a commit that fixes the broken code, a build is triggered in Travis CI once more. We'll fast forward through this. And once the build succeeds, we again get a notification on the Slack channel with the coverage details. And at that point, the assignee can go in and close the issue and add any comments that they'd like to. And again, if we've included the fixes keyword in the original commit message, then this will already be closed. For our third use case demonstration, we'll be showing how CiBot reacts to coverage loss and the options it gives you to respond to it. So first we'll make a commit that decreases the code coverage, and we'll do this by commenting out this test. And when we make the commit, again, Travis triggers a build. And as we can see, the build has succeeded, but if we refresh this page, the coverage has drastically decreased. And as we can see here, we've received a notification about this decrease in coverage on the proper channel. And similar to the build failures, we can create and assign an issue using CiBot. And as we can see, an issue has again been created with the proper title and assignees. And the remainder of the video will be showing again the rounding out of this third use case with resolving the coverage loss and pushing it to the repo. So here's where the assignee can go in and fix the offending code, make a commit. Travis will trigger a build. And we can see coverage has returned to an acceptable level, and we get a message saying as much in the Slack channel. And the assignee is then free to go in and close the issue.